Hi guys, welcome to Versatility 2023. Um, I'm Sridhar Iyer, the Director of Machine Learning and AI at Versa Networks, and I'll be covering up some of the latest innovations we have within Versa Networks in the context of machine learning and AI, and how we are leveraging new cutting-edge techniques to improve your experience managing your network. Now let's look at the way business is conducted as usual across the industry. In a typical deployment network, you have different kind of sprawl. You have remote branches where your users are connected to. You have users using Versa SASE or VPN clients to connect to Versa networks. You have other remote users who are directly accessing different SaaS apps without going through a SD-WAN. Now, what you have is a lot of multi-network, multi-vendor networking devices, such as routers, switches, firewall, load balancers, etc. And all these devices are monitored in a non-standard way. So some of them are monitored using SNMP, some of them using the REST APIs that they expose, or yet others are monitored using HTTP ping to monitor these devices. And we are still relying on decades-old standard like SNMP, which was done in 1988 to monitor mega-scale infrastructure. And all you have been doing is uh, trying to figure out MIB to maybe go over the different SD-WAN paths, or maybe go over the SLAs. And this is not what SNMP was designed to do. SNMP was designed to do go over a lot of devices with which didn't have a lot of feature set. So it was easier to do it then. But now to make it all work, you'll need to get an expensive NMS software. You loop through NMS MIB or REST APIs, which is still going to be inefficient. And on top of that, you need a team of engineers working on this network management tool. You'll have to set up regional NOCs to make sure that your regions are up and running. And on top of that, you need to have a carefully crafted set of rules to manage all these alerts that you're generating, right? So we are making a step in the right direction. So we have smart logging where we push logs from each device in the standard format. So Versa, along with the rest of the industries, have been doing that. So we push the logs in syslog format, IPFix format, or protobuf format, which are easier to parse, which are easily parsable by machines. And we only send logs when needed. So if we are trying to monitor network bandwidth, in a typical SNMP scenario, you would keep on polling the same interface for the bandwidth data every few minutes. But with the logs that we have, for example, in Versa Analytics, the logs will be generated only when there's a traffic being sent on that particular interface, right? But the problem of data overload still exists, and the onus is still on user. They need to set up alerting and threshold for each signal and features, and they need to prioritize the alerts that are generated, right? So now AIOPS comes to the rescue. And how does it do that? The first tool we have in our ensemble of software is Vani, which is Versa Advanced Network Insights. And the problem sets that we are trying to solve are multifaceted. So we want real-time network predictive notification. Now, real-time predictive notification can be used for either capacity planning or detecting some issue way ahead in the future, not just when it hits certain threshold. So for example, branch X might see a surge in traffic in 15 minutes or maybe the next 1 week. So I need to get the bandwidth or get capacity planning done a week in advance, which is much easier than when you start hitting those threshold and the congestion limits on your existing circuits. That segues into doing predictive network design, that we can tell you what kind of SLAs or what kind of latency your apps might notice day in, day out, or maybe based on time of the day or the day of the month. If we can figure out the trends for you, so you can use that for planning your network design. We can do anomaly detection based on raw logs. not just based on some arbitrary threshold that somebody would set. So we can figure out that, hey, that this guy access a subnet that he never accesses before, or an application that he never uses, or maybe it's an application that he uses, but suddenly he has started using it at midnight and has started downloading a lot of data. So we automatically detect all of that without any input from the user. And again, with all the alarms that we generate, we try to uh, do alarm correlation. So alarm correlation and suppression. And why is that important? So let's say you have a small network of 10 branches, and a branch one goes down. Now, branch one goes down, that means it's not generating any alarm for you. All the other branches are generating their own alarms. And on top of that, you get alarms like IPsec went down, IKE went down, BGP went down. So just for branch one going down, all the other branches are generating dependent alarms. So we need to correlate all of this together and say that, hey, in reality, there are 40 alarms, but what actually happened was just branch A went down. And we need to present a suppressed alarm view to the user just to reduce the alarm fatigue from the operations, right? And all of this ties into smart debugging, where we can use all this intelligence and the troubleshooting know-how of our network engineers and productize it so that using a chatbot or an NLP front end, we can tie it all together. So let's look at alarm suppression and prioritization. So as I mentioned, if you log into Wani, the first screen will give you the most independent cause of alarms. It will suppress and correlate into simpler data points. So if you want, of course, if you want a granular view of what's happening in the system, Versa Director and Versa Analytics is still there. But this is from a view of a bird's eye view of what's happening in the system. So you notice for example, the last column that you see is stability alarms. Stability alarms include everything from BGP, IKE, IPsec, branch disconnects, GRE link failures. So I'm not going to enumerate all of those. I just club them all together into stability issues. So this just shows that, hey, there was some stability issues on that particular branch, right? Now, more than after we suppress these alarms, it's our job to prioritize what you're seeing what issues you're seeing all over the world. Because if you have a network sprawl that goes all around the world, you need to be figure out what's your action item, what you need to look at in advance, what you need to prioritize. So in this case, you would see that, hey, I've already prioritized based on the fact that there was no issues on this box earlier, and now suddenly we see some issues propping up on the box. And based on those independent alarms that I found, so you can directly go into those devices and figure out what's happening there. So it gives you an actionable insight as to what to do with all the alarms that are coming in. And this would make more sense when I go into the demo. Now, the next engine that Wani supports is network signal prediction. And we can predict any network signal. In this case, I'm showing received traffic on a particular branch on a particular interface. So we have granular models that look into each device and each interface and create granular models for each of those and predict them a week in advance. So this directly gets us a bunch of features like capacity planning that I can tell you a week in advance whether your configured bandwidth is going to exceed the your predicted bandwidth is going to exceed the configured bandwidth, or maybe the current bandwidth exceeds the predicted band by a certain amount. So that's automatically triggers an anomaly alarm that you can directly take a look at. And the possibilities for this prediction engine are endless, because you can use the same thing to predict SLAs. You can use this to predict latency, application link performance, your voice video quality, whatever you're monitoring, whatever signals you are monitoring. You can predict how it's going to behave in the next 1 week, and you can use anomaly algorithms on these directly, right? So the next engine that we do support is anomaly detection engine, and this is needed to find anomalies from raw event logs. So if you have a bunch of different logs, for example, in this case, event logs, each event would be a 10-minute compressed log of what app the user was visiting, or how many sessions to that app, how many files were downloaded and at what time. And using just those information, we can figure out what the anomalies are. We can pinpoint the events that are anomalous uh, in a haystack of all the alarms that we have. Now, this nicely segues into UEBA, which is our user and entity behavior analytics, which uses some of the same engines that we have described for networking. And in this case, we have a certain configured set of anomalies, for example, impossible travel, which means a user logged in from country X, and then within a few minutes, he logged in from a different location, which he couldn't have traveled that fast. So that's considered impossible travel. Or he traveled to a country for the first time, or a set of risky country that has been configured by the customer, or maybe he downloaded too many files that typically he doesn't download. And all of this is either config driven, or the auto threshold detection engines have automatically figured out that this is an unusual download or upload by this particular user. And all of this is clustered together. This is a multi-tenant solution, so it is all clustered together by tenant. So you can delve deeper into what has happened by that particular user, what that particular user has done. And each of these events have an event severity score, which are all combined into a user confidence score. So when that will ding the it would be something like a credit score that would be dinged by every time he does an event. There's an event that is attributed to him. For example, in this case, a user who is detected from this particular IP, if the rule is hit, then his score is dinged to 97, and correspondingly, a band would be created for him. Now, if you're using Versa messaging server, that would further disseminate this information to all the VOS devices, and VOS devices will have configuration to accordingly log this customer out, or stop him from getting into the network or downloading files, or whatever they choose to do. So the possibilities are endless. Now, what we are also doing is we are directing all the logs that we are getting for a particular user into a graph database, and we are doing detailed graph analysis. So we can do log correlations, we can do community detection. So for example, if a particular user is maybe malicious, or it's detected that he is on a compromised system, who else could be affected just because he is affected? So we can do a blast radius detection, right? We can find similar set of users using the off-the-shelf community detection algorithms. We can use this for micro-segmentation to push configuration rules to the end devices where the customer is logged in from. And we can use them for anomaly detection as well. So, hey, there is a separate app that this particular user is using, and he typically doesn't use it. Or maybe these two guys are communicating via this app when they never did in the past. So we can do all sort of analysis with the rich set of graphs that we are doing. And we in the future, we are also going to add a lot of MITRE queries that will write MITRE queries on top of this graph directly. That so the in the greenfield deployment, the existing users will automatically get a benefit of this kind of detailed graph analysis. And now the next use case, and now the next product we have is Verba, which is Versa Chatbot. And what that is intuitive access that is built into all the Versa control plane, whether it's Concerto or Director, and it provides a very easy way to interact with the system, right? So what it does is it provides a context-sensitive window for the user to interact with, and you can type whatever you want, and it'll help you troubleshoot some of the common problems, and it will redirect you to appropriate UI screens if you need it to be, right? And we are trying to provide arbitrary search capabilities for everything Versa. So if we don't automate certain things, it'll redirect you to the appropriate web page or appropriate docs page to look up those things. And we are constantly improving the chatbot, trying to add as many features as we can, trying to help you debug as many common features as you have. And of course, we like to work with as many customers as possible so that we try to reduce the load on their knock as well. Now let's tying it all together. What we know is when we started, we all had data plane, and suddenly with the software-defined movement, we had a separate control plane, and that became the pillars of traditional networking. Now, what we have done is we have introduced an intelligence plane where we are using the existing knowledge which is outside the control plane, prediction and insights to kind of affect what the control plane does to affect the data in the data plane, right? So if we are trying to architect the intelligence layer, we are trying to create an ML-enabled device at the edge. So even our VOS devices have edge machine learning use cases, which are enhancing the way they route the traffic, and they scan the traffic or even filter the traffic out before they send it to sandbox. And all that is done without the user knowledge automatically. Then they're sending the logs to analytics server, which is enhanced by Vani AI. And so the analytics server is sending logs to Vani via Kafka bus, which can generate multiple insights and alerts, which can be fed back into VMS to affect the VOS devices. And to close the self-healing loop, our chatbot Verbo understands what needs to be done, how to troubleshoot a typical issue. So now, if you want to tie it all together, Vani will tell you what issues you're going to face in the future, and Verbo is going to tell you how to fix them, fix these issues. So tying it all together, you'll be able to fix the issues that are going to happen in the future. Now that's an incredibly interesting idea, and I do hope that we are there for the ride. And with that, I'd like to thank all of you for watching these slides. Before now, I'd like to go over to the demo to kind of kind of explain how these things are and how these things are working. So now this is a typical director screen. This is running 22.1. This is one of the new UIs that you'll be able to get. But chatbot is supported in since version 21.2.2, 2.3. And now chatbot is what the use of chatbot in this case is. We are trying to figure out these are my branch devices, and I want to figure out what issues each devices have. So now you can just see that branch one is currently unreachable. So we want to figure out why that is. So let's ask chatbot. So hey, branch, okay. I'll say okay, branch one. So now it's smart enough. So if there's any formatting issues or any of that, it'll ask me. It'll confirm that that's what I meant. And in typical production scenarios, your branches might be labeled to have location and all of that, and we don't want you to type the whole name as such. So this will help you or do an autocomplete kind of a thing and tell you, confirm whether this is the right branch or not. All right. So lab 20. Yes. So now when I do that, it starts executing a bunch of troubleshooting steps automatically in the backend on director backend, right? And even though your director backend might not be exposed to the internet, the screen that you're using, the UI that you're using, it's using the cloud to kind of convert what you want to figure out on the internet. So it's using the cloud to do intent analysis, but the actual work is done on the director backend. So your data and your information is never leaving on-prem, right? So you see that it has already gone through a bunch of steps. It has figured out, okay, there is not reachable, your branch is not reachable. It's trying to check the overlay route. It's trying to look at director next hop, southbound is reachable. Now I could have directly gone to the answers directly, but I want to show that the chatbot is doing its job and it's going through the a bunch of rest of steps that is needed. So I'm showing you the inner working. I don't need to, but I'm showing you the inner working so that you have more confidence in how chatbot works. And now, finally, you'll be able to download a chat script which shows the inner working of what the chatbot does. And it's not just what you asked. It's also that a chatbot, what commands the chatbot is using to figure out if there's an issue. He's using pings, he can be using TCP dump, he can be looking at device configuration, he can be parsing out the device configuration, he can be looking at different configuration on the controller. He can be calling monitor commands, he can be calling TCP dumps, and it does all the parsing for you in the backend, and it finally tells you what the issue is finally. So you can directly attach this whole chat script to your ticketing system. And what it gives the TAC guys or the people who are debugging your network, they get a leg up that some of the steps have already been taken. And in some cases, they can directly look at the final answer as to figure out, oh, X is not done, and let me go ahead and do X. So it improves your debugging process. It makes it incredibly faster for your TAC support team and the operations to manage a network of a global size by using these automated engines, right? Uh, Now, with that, I would like to move to Vani, which is Versa Advanced Network Insight. Now, again, this is an actual dashboard with an actual customer, which is why we have obfuscated the names here. So if you look at this particular dashboard, you automatically see um, the priorities of that these sites have been prioritized automatically based on how often they've seen certain issues or what issues they have seen. And each of these boxes are clustered by region that I can just go into the details. I can just uh, drill down as much as I want, and it behaves exactly how you expect it to behave. These will all get clustered and everything changes accordingly. Now let's look at a sample site to see what's happening. This particular site says 4:34 of the last week, 8:23 memory utilization issues occurred in the past day. So here we have a graph of the last couple of days, last 1 week on this particular device, where you're seeing memory utilization issues, and you have been noticing memory utilization issues only in the past 2-3 days. So now this gives you a big impetus to just go into that particular site and figure out what's happening, right? Now we are building expertise right now where Vani where Verbo will be tied in directly. So not only it will say that this is the issue that's been happening on this device, it will also tell you why those issues are happening. So you don't need to go to this particular site to figure out what's happening. So it's going to give you a lot more actionable insight, right? So let's look at the bandwidth data that we have, which is a predictive data. So here the model was generated on Feb 10th and it's good till Feb 18th. So you can see that this red band is the prediction interval. This dotted line is some sort of a median prediction. And the dark line that you see is the actual traffic. And this is where we are right now. And what it does is on a particular interface, it's telling you how the traffic is behaving. So you can see that it's following the pattern pretty nicely. There are cases where it's exceeding, there are spikes, and these are generated as alarms that, hey, suddenly I saw a spike in traffic. Typically, it sends the traffic is less than 12 Mbps, but I'm receiving close to like 20 Mbps. So maybe I need to generate an alarm for this, right? Similarly, if you look at anomaly map, we do the same thing. We try to figure out what's anomalous on this uh, based on the event logs on the sites, and we try to prioritize that automatically. And based on the priority, you can directly go and look onto those devices and see what alerts or what anomalies those boxes are, and the view that you get is actually the same. It's just the same details. So for the same appliance, you can just look at the bandwidth charts, the weekly breakdown, as I mentioned. You also have anomalies. So what are the anomalies, for example, in this case, right? So here, if the user was configured, we would have gotten the username here, but here they have chosen not to expose the username to us directly. So the anomalous application automatically stands out. So anomaly means something that the other guys are not doing. So this particular user is using MailChimp. There's nobody else on the network who uses MailChimp or even Datadog that stands out. Maybe he's doing taxes, so in on the company network, so that stands out as an anomaly. You can just go into details into how many sessions have been opened, how many traffic, what traffic has been sent. So this gives you a detailed insights into what is happening. And this guy is playing, for example, a game, Roblox or something. It gives you an insight into how much data he's transferring, how many sessions he had, and this is all automatic. We are not doing um, uh, anything manually. Everything is automatically caught by the anomaly detection engine. And if we segue into UEBA, similarly, this is the same chart that I showed you the screen capture on. So this is a multi-tenant setup, and if I go to the core inline customer, that's inline customer, you can see how many impossible travel alerts were generated, when they were generated, and I can just go into the detail as to when that was, how many anomalies were done at what time, so I can look into what was happening in the system at that time. Maybe a lot of users came from US to America, US to from India for the conference or something like that, right? So this has to be validated by the network team, and they can figure out what's happening in the system. Now I can go into the detail of each of these users. This will update, and it will say that what are the different issues that this particular user did. Maybe he accessed some IP from a different country. Some rule was hit, and all of this is done based on the configuration or the ML that's been configured again from the UEBA screens on Versa Director or any of the configuration engines. So this gives you a kind of a bird's eye view of what Vani does, which is prediction and analysis, and Verbo, which is like a troubleshooting engine and an NLP front end to everything. And again, this NLP front end can tie together Director, Analytics, Concerto, Avani, any of the Versa products. It gives you a natural language front end for everything, right? So these are the two products that these are the two main products that we'd like to say to show you. And with that, I'd like to thank all of you guys for looking at the slides and attending Versatility 2023. Hope you have a good day. Thank you.